Okay, so we're going to be doing Chapter 10, Quiz 2 of my new book, Overcoming ACT Math by Sophia Garcia. If you're interested in getting it, it's available on Amazon. So let's get started. Really quick, before you do the questions, if you have already purchased the book before me releasing this video, there was just a quick little typo that I wanted to make you guys aware of. So for number 3, the answer choices have changed, and it is basically, I would treat it as a free response question right now. And if you have bought this prior to, what's today's date, like August 21st, 2023, then just treat that as a free response and go to the video to see the correct answer after. So let's go to number 1. It says, Lawrence buys his wife 3 types of flowers for their anniversary. The 3 types of flowers are roses, daisies, and tulips. 1/3 of the flowers are roses, 1/4 are daisies, and 200 flowers are tulips. How many flowers did Lawrence buy for his wife? Okay, so to find out the fraction of tulips, because if we find out the fraction of tulips, we can set that equal as an equation equal to 200. We could say that the fraction of tulips is going to be the 1 whole minus, and then it's going to be 1/3 of the roses minus the part that is daisies, and that would give us what part is tulips. So we want to have a common denominator when we're adding and subtracting fractions. So 1/1 can be turned into 12/12 if we multiply by 12 there. So this would be 12/12. And then 1/3, if we multiply by 4, we can get a 12 on the bottom, a common denominator of 12 on the bottom, and up top it would be 4. And we would multiply by 3 over here to get -3/12. So then when we do that, that's going to be, that would be 5/12. So 5/12 of the total number of flowers is going to be tulips. Now they told us that there's 200 tulips. So that means 5/12 times the X total amount of flowers is going to equal 200. So now all we have to do is divide by 5/12 to get X by itself, and we'll have the total number of flowers. So X is going to equal 200, I'm going to write it up here, 200 divided by 5/12. Now remember, when we divide with fractions, we have to keep, change, flip, KCF. So we're going to keep the 200, we're going to change the division to multiplication, and we're going to flip 5/12 to become 12/5. Now, we could say that 5 goes into 5 one time, and it goes into 240 times. And then we can multiply across. 40 times 12 is going to be 480. So that's going to be B right over there. So you could also have multiplied this all out and then simplified. You don't have to necessarily cross-cancel, but I did to save myself time. So then let's go to number 2. It says, a baker makes 2 cakes. The first cake is in the shape of a square with a side length of 12 inches. So let's draw that first cake. So it's a square, and the sides are all 12 inches long. The second cake is in the shape of a rectangle with a width of 8 inches. So let's draw that. And the width on each side is going to be 8 inches. If both cakes have the same area, then what is the length? So we're finding length of the rectangular cake. So let's label that as L. So they have the same area. So let's find the area of the square one. That would just be 12 times 12, which is 144. And since this has the same area, we would know that this has to have an area of 144 as well. Well, how do we find the area of a rectangle? It's just length times width. So 8 times L has to equal 144. So now we're going to divide by 8 on each side, and when we do that, we get that L is equal to 18. So it would be J. So let's now go to number 3. So ignore these answer choices. That's a typo that I fixed later. So for the value of X, we have this is equal to this. So first of all, I'm going to say, remember that this is kind of like saying -1 times all of that. So you can kind of think of that like separately on the outside to make this easier. And then we could say that it's equal to, and then think the same thing again for the -1/28. -1/128 is what I mean. So we could say that these cancel out. So then we just have 2 to the x plus 5 is equal to 1 over 128. Now, whenever you see problems that are set up like this, where it's like an equation in the exponent, you usually need to make these have like bases somehow. So you have to ask yourself, hey, how can I rewrite 1 over 128 as 2 to some power so that they have the same base? So let's think. 1 over 128 is the same thing as saying 1 over, that would be 2 to the 7th. So we could say 2x plus 5 to the x plus 5 is equal to 1 over 2 to the 7th. Now remember, negative exponent rule says that this is equivalent to 2 to the negative 7th. Because negative exponent rule says if we have a negative exponent, we just put a 1 on top and make the whole thing positive on bottom. So it's kind of like the reverse of what most people are used to. And then we have that that's all equal now to 2 to the x plus 5. So now we have like bases. So that means 2 raised to this equals 2 raised to that. That means that the exponents must be equal for this to work. So x plus 5 must equal negative 7. So let's subtract 5 on each side. It's going to cancel out there, and then we get x is equal to negative 12. So that should be the answer for number 3. So then let's go to number 4. It says, assume 200 is greater than 3x plus 6y, and x is greater than or equal to 15. If y is an integer, then what must be true about y? Okay, so x is greater than or equal to 15. So let's assume that x is exactly 15. So we're going to plug in, because it says it could be greater than or equal to. So let's plug in 15 for x over here and see what we get for y. So 3 times 15 is 45. So we would have 200 is greater than 45 plus 6y. Then if we subtract 45 on each side, we would get, that's going to be, let me think for a second, 155. 155 is greater than 6y. So now what we're going to do is we're going to say, okay, we have to get y by itself, as seen in the answer choices. So we're going to divide by 6. So 155 divided by 6, that would be 25.83 repeating. So let me try that again. 25.83 repeating. Y has to be less than that. Now they said y had to be an integer, so we know it's going to be either f or g from that right there, because this is, because when we plug in 15, it means that this has to be some number less than all of that. Y has to be less than 25.83, but it has to be an integer, so it can't have like a decimal after it or a fractional amount, anything like that. So what we can do now is we can say, I mean, you could reason in your head kind of like mentally to like see what kind of makes sense there. But I think that the easier way to kind of like check this also is to just go to like say x equals 17 and plug that in and just see like what the pattern is what most people should probably be doing. That would confuse like the least amount of people, I think. So we're going to say, okay, now let's plug in 17 because it could be 15 or some number higher. So we're going to plug in 17 now. So then 3 times 17, that's going to be, hold on, that is 51, yeah. So then that's going to be, if we subtract 51 on each side, we get 149. So that's 149 is greater than 6y. So now if we divide by 6, we're going to get that it is 24.83 repeating, and that y has to be less than that. So it keeps going down, so that tracks with it either having to be f or g. So you see like there's a pattern of it going down. Now, y can be 25 because it just has to be an integer that's less than this. So y can be 25 or a number less than that if we're thinking of y as just an integer. So it could be less than or equal to 25, g. So then someone said something. Hold on. Someone said, how do you get 17? Oh, I'm just picking a number. You could have picked like 16 or 18 or whatever. I just, like, the first number that came to my head that was bigger than 15, I just did 17. Because that's a number that's greater than or equal to 15, and we already tried 15. Okay, so someone asked how long will I be live for? I'm doing 2 quizzes on live, so however long that takes. Okay, so let's, why wasn't negative 12 there for number 3? Because I made a typo, and this is one of the old books. I fixed it in the new version. So then let's go to number 5. Candy Corporate makes gourmet candy. They make 4 different flavored chocolates and 5 different flavored candy canes. At their new store, Candy Corporate will display 1 packet of each flavor of its entire line of candies in a row on a shelf. On opening day for their new store, the company intends to add 2 different flavors of sour candies to its line of candies. In how many additional orders will Candy Corporate be able to organize the candies on the shelf with the new line of sour candies versus without the sour candies? Okay, so let's think when they get these new candies, it's 2 new flavors of sour candies. They already had 4 and 5 other candies. So if we have 4, 5 plus 2, that's going to be 11. So for those 11 candies, the number of ways that we can arrange them is represented by 11 factorial. Now, they want to know the difference between now when we have those 2 additional sour candy flavors versus previously how many arrangements when we had only the 4 and the 5, which is 9 in total. So before we only had 4 chocolates and we had 5 candy canes. So that means we had 9 candies that we were arranging on the shelf. I think they said it was a shelf. Yeah. We had 9 candies we're arranging on the shelf before. So to find the number of arrangements then, it would have been 9 factorial. So if we want to find the difference between now versus then, it would be 11 factorial minus 9 factorial, which would be B. So then let's go to number 6. It says if a line passes through these 2 points, what is the slope of the line? So this is just the slope formula. So you can label your points any way you'd like, as long as like the little 2's go together and the little 1's go together. So like I could have made this x2, y2 and this one x1, y1 if I want to. It just matters that the little numbers go together, the 1 and the 1 and the 2 and the 2. And the slope formula says that the slope m is equal to y2 minus y1 over x2 minus x1. So that means the slope, what we're looking for, is going to be equal to, if I plug these in, it's going to be 7 minus 3 over 4 minus negative 2. So let's start with the numerator. 7 minus 3 is 4. And then on the bottom, it says 4 minus negative 2. Minus a minus is a plus. So then this is going to become 6. Oops. And then we want to divide by the greatest common factor to simplify our fractions. So the greatest number that goes into both of these evenly would be 2. So we're going to divide by that on top and bottom, and we're going to get 2/3 when we do that. So it would be J. Oops. Okay. So let's go to number 7. It says the expression right here is equivalent to. So right here, whenever I see these, I kind of like to think about it as like pairing the numbers, the x's, and the y's together, or like whatever the variables happen to be. Like pair the like things together and do quotient rule, essentially, for the exponent stuff. So negative 56 over 7, that's just going to be negative 8. Now I'm going to pair up the x's together. So remember, when it has no exponent, we're supposed to assume that there's a 1 as the exponent there. We just, for some reason, don't write it in math. So if I'm going to use quotient rule with x cubed and x to the first power, quotient rule says if you're dividing between like bases, you subtract the exponents and keep the like base. So 3 minus 1 is 2. Now we're going to do the same thing with the y's. We're going to say, okay, we're going to keep the like base of y, and we're going to say 2 minus negative 2. Now 2 minus negative 2, minus a minus is a plus, so that would have to be to the 4th power. So it would have to be C. Thank you for the rose. Let me just get some water really quick. This is for the ACT for people asking, but a lot of this will help you prepare for other exams as well, such as the SAT. So let's go to number 8. for triangle ABC, if AB is equal to 6 and BC is equal to 10, then what value of AC would cause triangle ABC to be obtuse and scalene? Okay, so for it to be obtuse, so this is one of like the extra kind of formula things that you could memorize. It's not as likely as other stuff to show up on the exam, but this is what it's saying basically. So you know how like with Pythagorean theorem we have a squared plus b squared equals c squared? Well, if a squared plus b squared is less than c squared, we can, oops, I meant to say c squared, is less than c squared, then we can say that that triangle is obtuse. And the opposite is positive for like acute. If it flips and it's a greater than sign, then it's acute, but we're looking for obtuse here. And scalene just means that every single side is different. That's all that means. So let's plug these in, and let's say 6 squared plus 10 squared has to be less than c squared. And remember, with triangles, also, if you have two sides and you're looking for the third side, there's a rule that also says if we subtract the other two sides, 10 minus 6, and we add those two sides, the third side has to be in between those. I think that's called like the triangle inequality theorem or something. So then it's 4, and then this would be 16. So it has to be a number between 4 and 16, and then it also has to follow whatever this is. So 6 squared is 36, 10 squared is 100, and that's going to be less than c squared. So we have 136 is less than c squared. So c has to be a number between 4 and 16. So we can cross out the 4 and we can cross out the 16 automatically. And now we can kind of just plug in these. I mean, you could do the square root if you want to, but I think it's easier to just say like 8 squared obviously is not greater, 11 squared is not greater, and then 12 squared is the only one that's greater. So it would be J. So someone said you lost me on this one. Basically, for this one, there's 2 rules about triangles. The one you're more likely to be tested on, I feel like, is this one, where it says that the third side that you're looking for has to be in between the other two sides subtracted and the other two sides added. And then for these over here, it says a squared plus b squared is less than c squared. That would be like one of the formulas you can memorize for obtuse. Like that, you know it's an obtuse triangle, basically. So let's go to number 9. It says, for triangle ABC shown below, what is the length of BD in inches? So we're trying to find this guy right here. Assume that triangle ABC is a right triangle. So we're going to say this is a right angle, sorry. Angle ABC, I said that wrong, is a right angle. And that angle BDC is supplementary to ABC. So if it's supplementary, that means they add up to 180. So that means this angle plus this angle equal 180. Well, this one's already 90. So that means this one also has to be 90 because 90 plus 90 is 180. All side lengths are given in inches and all angles are given in degrees. Okay, so we're trying to find this side length right here, BD. So let's think, okay. So this is a 90-degree angle, and I see that there's like a triangle right here, BDC, right over there. This is a right triangle. This is 60 degrees. I know that this is 90 degrees, so that means this has to be right here 30 degrees. So it's a special right triangle, a 30, 60, 90 special right triangle. So with 30, 60, 90 special right triangles, we know that the hypotenuse is equal to 2x. We know that the side across from the 30, which would be DC right here, is equal to x, and the side across from the 60 is equal to x root 3. So if we use this equation to solve for x, we could just say x root 3 is what BD is equal to. So I'm going to divide by 2 on each side, and I'm going to get that x is equal to 5. So x is equal to 5. We want this side, which is equal to x root 3, so we're going to say it's 5 root 3. So it would have to be B.